Hello, everyone who's joined us today. I'd like to welcome you to the final installment of the three-part webinar series that we've been running over the past few weeks to explore some of the scientific, policy, economic, and community perspectives on the changing Northwest Atlantic Ocean. Before we go any further, I want to say a big thanks to our sponsors of this program, the U.S. Embassy in Canada, which provided us funding through their virtual engagement program. Thank you so much to the embassy. I'm Jake Kreitzer. I'm the executive director of NERACOOS, which is part of the U.S. Integrated Ocean Observing System, one of your co-hosts for today. And I'll turn it over to my fellow host now.
Thanks, Jake. My name is Shayla Fitzsimmons, and I am the Executive Director of CIOOS Atlantic, which is the Atlantic Regional Association of the Canadian Integrated Ocean Observing System. Now, throughout this series, we've been following the ongoing voyage of the U.S. Coast Guard cutter Healy, from the research conducted during its historic transit of the Northwest Passage and then in Baffin Bay, continuing south past Newfoundland and Labrador, to the focus of today's program, which is the Scotian Shelf and the Gulf of Maine. And this is really where CIOOS Atlantic and NERACOOS work together.
So later in the program, we're going to learn a little bit more about some of the scientific operations aboard Healy. Afterwards, we'll hear from two expert panels. One will be focused on some of the scientific work being done, and then the other will be looking at some of the more human dimensions associated with our changing ocean. But before we get to all that, we're really excited to welcome some opening remarks from three very prominent voices on ocean science and policy. First up, we're going to share with you a recorded message from U.S. Senator Angus King, who represents the state of Maine, where he was formerly governor. Senator King, for those of us who live in the northeastern U.S., has long been a champion for the ocean. And he's also been a real leader on kind of making the scientific, economic, and policy case for the strong connections that exist between the Gulf of Maine and the Arctic. So let's hear right now what Senator King has to say.
NERACOOS, the Ocean Observing System. I remember back 25 years ago as governor of Maine when we started what we called Go Moose. Naturally, that was the Gulf of Maine Ocean Observing System. So I feel like I have a connection to your organization because that was something that we thought would be very important, and it's still obviously important today. The basis of all good policy is data. The basis of all good policy is data. And that's the essence of what you're doing, of what your organization is doing. Now, it's not just the Gulf of Maine, but it's the entire East Coast and up into the Arctic. And I know the crew of the Healy knows about good data and good information. And they're now moving down toward the Gulf of Maine. And so this is the work that you do that's so important to enabling us to understand what's happening in climate change, to understand what's happening in these critical ocean areas off our shores. And so I just want to thank you for what you're doing. I believe that you recently got an appropriation that's going to be helpful to your organization. I certainly hope so. But fundamentally, what I want to do is stress how important what you're doing is. I can't imagine a time when having complete and accurate data about what's going on in the ocean is more important because we're moving into this period of what I'm afraid is accelerating climate change. We're all trying to find ways to ameliorate it and to mitigate it, to slow it down. But the reality is it's there, and you're providing the information that will enable us to develop good policy in response to what's happening in the world around us. So congratulations on what you're doing. I appreciate the opportunity to join you, and thank you for the work on behalf of the oceans, the coastal states, and the United States of America.
Well, I really want to thank Senator King for those wonderful remarks. He focused quite a bit, obviously, on our organization, NERACOOS, and certainly his very long personal history with the organization. But I think a lot of what he had to say about the importance of good data and the imperative of responding to climate change equally applies to our partners at CIOOS Atlantic.
That's absolutely correct, Jake, and it's really exciting to hear Senator King share his thoughts and know that there's such a strong advocate in our neighboring waters for what we both do. Now we're really excited to hear remarks from Nicole LeBoeuf and Vladimir Ryabinin, after which we'll have 10 minutes or so for a Q&A period with them together. If you'd like us to ask Nicole and Vladimir a question, please do enter it into the chat box and we'll do our best to get to as many as possible.
So it's my pleasure now to first introduce Nicole LeBoeuf, who is the Assistant Administrator for NOAA's National Ocean Service. That is the home to the U.S. Integrated Ocean Observing System, among a number of other really important programs. Nicole has had incredibly widely varied and deep experience over her career on the connections between science and policy, which includes several international appointments, which is kind of relevant to this series. So it's great to have you here, Nicole, and I'm looking forward to what you have to say.
All right, good afternoon, everyone, and many thanks to you, Jake Kreitzer, and the entire NERACOOS team for inviting me to participate in today's event. And of course, it's so nice to hear those glowing remarks from Senator King. What a fan of our work. We know the importance of the IUS regional associations in supporting national and global ocean observation efforts, but it's rewarding to hear others' recognition of that work as well. And I am thrilled to reconnect with Vladimir, and I would just like to acknowledge his visionary and sustained leadership on the UN Decade of Ocean Science. Our work at NOAA directly supports the UN Decade as we provide authoritative science and services for a more equitable and new blue economy and a society that is resilient to the future, where climate change is simply a part of our world. Indeed, at NOAA, we are shifting our way of thinking from an ocean economy based entirely on extraction of limited resources to one of extracting information, the most renewable of all resources. Large-scale efforts that prioritize obtaining and sharing of information, such as the UN Decade for Ocean Science, are essential as they help us to achieve many goals, including protecting human health, tackling climate change, ensuring coastal resilience, and promoting economic prosperity. As our ocean and coast change at an accelerated rate, working together and sharing information and resources is the only way we're going to be able to meet our common goals. We count on organizations like NERACOOS as a trusted on-the-ground partner, working to encourage participation from all communities, including those traditionally underrepresented and often more vulnerable to the impacts of climate change. In fact, NERACOOS's longstanding and new relationships support NOAA's domestic and international agendas. This webinar series is a great opportunity to examine the ways that nations can work together to enhance ocean observations, addressing issues that are larger than any one country. And more than just neighbors, the United States and Canada have been long partners in the study and management of oceanic and coastal areas. On behalf of the US IUS Program Office, we are thrilled to see the excellent progress of the Canadian Integrated Ocean Observing System. Ocean observing systems provide foundational data necessary to the understanding of natural systems and to support our sustainable use of ocean resources. The collaborative partnership between IUS and CIOOS allows us to leverage our national assets to approach issues at regional, national, and international scales as we detect multiple climate-related stressors on ocean and coastal areas. This collaborative work is especially important in places like the Arctic. We all know, and Canadians more than most, that the impacts of climate change are being acutely felt within the Arctic, and that these changes pose an enormous risk to communities in the Arctic and the ecosystems that they support. Foundational data is critical to many low-lying and remote Arctic communities, and many indigenous and coastal residents that face serious threats from storm surge, sea level rise, land subsidence, and shoreline erosion. US and Canadian data and decision support services are critical to meeting environmental, economic, and sociocultural needs of Arctic communities. That said, the pace of change is expanding their set of needs faster than we can fill them. NOAA is aware that Arctic communities have been historically underserved by climate and environmental data, products, and services. We are actively working to reduce barriers to resources for underserved and economically disadvantaged communities like those in the Arctic, and to make sure that our data, tools, and services are available, useful, and used as the rapid pace of climate change accelerates. We will continue to work with our partners in the region, like all of you, to provide near-time and real-time coastal and ocean data, information products, and tools to the public, including those who have been historically left out. The strong relationship between the United States and our closest neighbors in Canada is critical to this success. A heartfelt thank you to NERACOOS for helping bring us together in such a unique opportunity. I look forward to talking more with Vladimir and everyone about our role in advancing ocean observing to support healthy ocean systems in a changing world. And with that, I will close. Thank you very much.
Thank you very much for those excellent remarks, Nicole. I'd now like to welcome Dr. Vladimir Ryabinin, who is Executive Secretary of the UNESCO Intergovernmental Oceanographic Commission, which is home to the UN Decade of Ocean Science for Sustainable Development. Vladimir agreed to join us today after the series was endorsed as an official decade event, in honor about which we're very excited. He's an oceanographer, marine engineer, meteorologist, and climatologist, and also serves as Assistant Director General of UNESCO. Vladimir.
Thank you so much, Shayla, and also Jake for inviting me. And when Nicole was speaking, actually, I got excited, got inspired, and I put here, on this side, a pin of NOAA. So, it looks, of course, a bit strange, but I like it. So, ladies and gentlemen, thank you indeed for having IOC speak at your meeting. I don't have a prepared speech, but I would like to say that in preparation for this meeting, Jake shared with some colleagues several questions, and I think it will be appropriate for me just try to respond to those questions. But first of all, why the decade? Unlike, for example, the World Meteorological Organization that has a convention and countries are obliged to take meteorological and related observations and send the information in order to have global weather prediction, nothing of that sort exists in oceanography. So we are basically capitalizing on the goodwill of people and organizations. So that's exactly why we needed a campaign of that caliber as the decade to engage everyone. It was, I think, a risky undertaking to start that because it could have easily failed. Still, it is not easy, but I think we are getting there surprisingly because the momentum is getting higher and higher. And also, I think there is now more and more communication between different key partners. And I would like also to say that the decade was proclaimed within structures and resources. That means that United Nations was not offering us any money or any infrastructural support. But already now, in the result of the first call, we see that more than 30 different programs of the decade can operate a sum of money which is of the order of $800 million for the next 3 years. So, but the momentum is growing. But because of the same reason, we had to basically invite everyone to come to the decade. And we have now, I would say, in front of us a field of different activities that like I would say trees growing, and all these trees are totally different. Someone would like to do this, someone would like to do that, and we need to coordinate that. So, and I think in this particular case, what you are going to do in NERACOOS is, and also in the Canadian Integrated Ocean Observing System, is incredibly important because of the spectrum of activities. You know, at the level of the global level, there are some organizations like IOC that are trying to coordinate things. You know, and in terms of where the spectral energy is sitting, I think it's sitting in the regional oceanography. You know, all problems in the oceanography are largely, I would say, having regional implications and having regional observing systems and data processing, also predicting and ocean management systems seems to be working. We have large marine ecosystems, you know, and that approach is also working. And because of that, I think the focus on the local issues, work with local communities is incredibly, I think, efficient. Of course, we need to develop the global ocean observing system. And we all know that the standards have to be global, but they have to be used in the local context. And this is exactly what is happening as part of your project. You know, I would like also to say that this particular project, because of the high technical development of the countries involved, also high skill of participants, may serve as a prototype for some other regions. Maybe not in terms of the environmental conditions, but in terms of your focus, of your solutions. So this we hope to actually capitalize on this in working in different parts of the world with that. So now there was actually an interest in trying to explain how you can work with the indigenous communities. And indeed, the decade is now offering that opportunity. First of all, we have created already a forum in which you can register, and this is a discussion club. That is focusing on the issues we also that are relevant for you. We are also creating communities of practice, and these communities of practice I think will be really enriching, because you know decade is, as I said, has no original no money, but in principle it is basically a co-design exercise, an engagement exercise for the whole world. So please join certain communities of practice, and they will be, I think, very helpful for you. Money, you know, and I think I'm among the recent developments. I'm excited by some conclusions of this that we can find in the blue papers of a high-level panel for sustainable ocean economy. They speak about involving national accounting in oceanography. This is relatively new. You know, the easiest and simple way would be to see what is the GDP that is generated by through the ocean science and ocean applications. And there are estimates that globally it's of the order of $2 trillion equivalent. There is also an attempt to value ocean ecosystems, you know, and like very much one expression that, you know, this approach seriously underestimates the infinity. But in principle, I would like to say the following. So, you know, the value of ecosystems can be assessed, and it is possible to see whether this value is increasing because of the human work, appropriate work, or it is decreasing and the ecosystem sites overexploited or diminished, are neglected. But the third thing is totally new to me, at least. No, this is an understanding that we need to try to find a non-material or maybe a tangible expression of how ocean science results in well-being of people. And that is possible. And I think on the regional scale, this is also possible. So I would like to invite you to look into this and see how we can materialize that potential. And with that, I think the work with private partnerships, you know, and we are creating partnerships is becoming more and more fruitful, and you can have very strong partners. So that, I think, what we can offer to you, and I think you can be a leader in the decade. We are very happy that we provided to the world that platform that apparently is working and engaging people. And I would like to say that there was on the 15th of October, so it's 5 days ago, we issued the second call for actions. The deadline, excuse me, please, is for submissions is 31st of January. And the focus of that decade call number 2 is ocean pollution, ocean ecosystem health, and ocean climate nexus. So we are really looking forward to, it's not actually closed for all other decade challenges. There are 10 challenges, and the ocean observations are always important. But you know, that was our attempt to start coordinating that that forest of different trees, so it becomes, you know, more or less universal in serving the society. So third workshop, I think you know, I was informed that they're doing really well, and you know, and just wish you good luck, continuation, you know, and after the workshop starts, very hard work. And we are working also very hard to provide you possibilities to be successful in your region and globally. Thank you so much. Good luck again.
Thank you so much, Vladimir, for those remarks, and to you too, Nicole. We don't have you both for much longer, but if you're okay, we have a couple questions that we'd like to follow up on those remarks. Is that okay? Thank you. So the first one I want to ask, I think really builds on a lot of what Vladimir just shared, but goes back to something you addressed right at the top, Nicole, and that's this concept of the new blue economy, which I find to be a really interesting, really interesting concept that I think is relevant to the work that us at NERACOOS and our partners at CIOOS Atlantic do. So, Nicole, I wanted to see if you could just talk a little bit more about this idea and what sets this new way of thinking apart from previous ways of doing things. And then Vladimir, I'd love to hear your reactions to what Nicole has to say as well.
Good.
Yeah, Jake, thank you. You're absolutely right. Vladimir, some of your very last remarks I wrote down. You commented the need for us to better apply ocean science for public good and well-being, and that's really the heart of the new blue economy. Although there are a lot of other good reasons out there to tap into ocean science. One of the inevitabilities that we're faced with climate change is that the rate of change is not only the fastest along the coasts and in the ocean, but it is accelerating. And what we know fundamentally about maintaining prosperous economies and durability over time with investment, et cetera, is that you have to have some degree of predictability. And so in the case of where change is fast and is accelerating, prediction is not, we've heard the phrase knowledge is power. I believe that prediction will be power. And to the degree that there are those involved in the public well-being, involved in profit making, emerging technologies and industries, as well as established ones, if they can move into the world of prediction for public good and again, for benefit, ocean science and coastal science will be at the center of that, because that is where there will inherently be the most unpredictability. The new blue economy acknowledges that and says, look, we can continue to take things from the ocean, whether that's oil and gas and fish and other limited resources, and we will. But as I said in my remarks, the most renewable resource is the extraction of information. And for those who are willing to acknowledge that and come to the coasts and the ocean and say, you know what, there is a wealth of information that if I can turn information into insight and into prediction, I can do so much for either my company or the public good. I believe those opportunities are going to open up exponentially along the coast and in the ocean. And that's not even to mention our increasing awareness of the ocean as a sink, as a driver of climate change, of the coasts as a potential, nature-based infrastructure, as a protective from the effects of climate change. I mean, I can go all day and talk about the benefits of better prediction and understanding along the coast and in the ocean. And that's what we're trying to do, is to communicate the wealth of understanding that brings opportunity and public good into this space where we have inherent unpredictability and change.
And thanks, Nicole. Vladimir, I think we'll need to wrap up in a moment, but I think this, again, this is such a compelling concept that Nicole has raised and just kind of expanded on, of the new blue economy, and it relates to a lot of what you'd said. But I think I'd love to hear any kind of closing thoughts on that before we thank you both for your time.
Thank you. I would like to continue the line of thought and would like to say that indeed there are very significant issues in the world related to climate change, related to loss of biodiversity, related to how people live, and and the COVID and the health. So, you know, and in principle, the response to such issues sometimes is not linear. In order to address biodiversity, you have to work in certain other areas. So I think through the ocean management that is oriented towards maximizing value in a sustainable way of the use of the ocean on the basis of science, it is possible to decarbonize ocean economy, to achieve conservation of biodiversity and restoration certain things, well, rebuilding or, you know, self-growth, and also contribute to the well-being of people. So science is the foundation of that, and the paradigm is sustainable ocean planning, that to which science has to contribute. I think this paradigm is now emerging, and there is more and more commitment. Canada is a member of high-level panel, so you're supposed to fulfill the commitment by 2025, excuse me, start managing the zone and the national jurisdiction sustainably. I think others will come. So I think that is the paradigm through which we'll be working. This is contribution to ocean economy, to people, and the environment, based on science.
Thanks, Vladimir. That was perfect. And to you as well, Nicole. I think you both really set the stage beautifully for everything we're going to cover for the rest of this webinar. So I want to really thank you again for your time and for your thoughtful remarks. I know you're both incredibly busy. Vladimir, I think you're heading right back into a meeting that you stepped away from. Nicole, I know what it's like to try to get your time, so I'm guessing you're running right off to something else as well. But we're really grateful for both of you, for making the time. Thank you.
Good luck. Thank you.
Thank you. Bye-bye.
So as we mentioned at the start of this webinar, we've across the series we've been tracking the ongoing voyage of the U.S. Coast Guard cutter Healy, which is in the middle of a complete circumnavigation of North America, which is kind of cool. We've been paying attention mostly to Healy's voyage from across the Northwest Atlantic, from the Arctic waters right down to our corner of the world here in the Gulf of Maine. In our first webinar, we spoke to Dr. Bob Picard, who's at the Woods Hole Oceanographic Institution, but at the time he was aboard Healy in the middle of Baffin Bay, serving as the chief scientist for that cruise. During the second webinar 2 weeks ago, we were joined by Dr. Larry Mayer, who works right down the road there at the University of New Hampshire, but he served as the chief scientist for Healy's research transit through the Northwest Passage. And those were really both quite fascinating discussions we had with Bob and Larry.
And today we're going to learn more about what goes into planning science operations aboard Healy from Dave Procucci, who is Healy's Marine Science Coordinator, as well as the data that Healy is always collecting while underway. We'll hear about that from Shawn Smith, who is the Director of Marine Data Center at Florida State University. We'll hear from Dave first, and then Shawn right after, and then take a few questions for them if we have time. So if you have any questions for them, please do enter them into the chat at any time. Dave.
Buddy, it's nice to be here. If I could have the first slide. So the Healy is operated and maintained by the U.S. Coast Guard. There we go. And began supporting agency-funded science in the Arctic in 2001. Healy's home port is in Seattle, Washington, shown here at dry dock. Next slide, please. Planning a research expedition on Healy has many moving parts, and scheduling is the longer time frame piece of the puzzle. When a scientist is getting ready to submit a research proposal, which requires an oceanographic vessel to an agency such as NSF, ONR, NOAA, they'll submit a ship time request to the University National Oceanographic Laboratory System, or UNOLS. Next slide, please. Just give you a little background. This is the UNOLS.org website, which uses a new interface, Marine Facilities Planning, to coordinate the entire U.S. research fleet to support funded oceanographic programs throughout US waters, and oceans around the world. So that's a lot of surface data that they're collecting. If a scientist needs a vessel for Arctic research, and the choices are limited since the US only has one high Arctic research vessel, the Healy, and one ice-capable vessel, the Cowasuk at the University of Alaska. Next slide, please. Just to give you an example, this is a slide of a screenshot of a marine facilities planning ship request for Healy in 2022 to go to the North Pole, and this was submitted by the chief scientist. In the past, the US Coast Guard evaluated these ship time requests, and working with the funding agency program managers determined which science programs would be scheduled on Healy. So for the years 2001 to 2020, this was the working model. Next slide, please. So as Jake mentioned, a pretty cool cruise that Healy went on this year. It's going to wrap around North America. But this was all a result of a change in the scheduling process where US Coast Guard missions became priority. And science on Healy is now ship of opportunity science and not driven by agency-funded programs. The ship of opportunity programs that participated in 2021 deployed via the Northwest Passage, you can see, and to the East Arctic. First time Healy's been there since 2003, and conducted a Baffin Bay Oceanographic cruise. And as Jake mentioned, you've heard about those from Larry and Bob. Most of the ocean and atmosphere data collected this year were from non-US waters. And the US Coast Guard obtained foreign research clearances for marine scientific research, MSR, via the State Department. Next slide, please. In the future, the US Coast Guard may solicit more ship of opportunity science programs for Healy through an announcement disseminated by the Arctic Icebreaker Coordinating Committee, the AICC, as was done for 2021. And this will be posted on the AICC link at the UNOLS website. So the ship opportunity science participation on Healy does not require funding for ship time, which is approximately $45,000 per day. So again, this is the ship of opportunity science will open it up to, can open it up to scientists that may not have had the opportunity to go on Healy. Scientists only need to fund their travel and their infrastructure they require on board. Next slide, please. For science planning, iceflow.net, its website, has an information about the Healy science systems and cruise planning. Healy has a comprehensive suite of underway sensors for sampling seawater and the atmosphere, as well as hull-mounted echo sounders, including multi-beam, sub-bottom profiler, and ADCPs, acoustic Doppler current profilers. And of course, has state-of-the-art CTD capability. Arctic ocean and atmosphere surface data are scarce, which makes high-quality data collection from Healy all the more valuable. And that's why the collaboration with Shawn Smith at SAMOS has been so important over the decades. And to talk more about SAMOS, I'll turn it over to Shawn.
All right, well, hello all. This is Shawn Smith from Florida State University. Thanks, Dave, for the intro, and actually that helped a lot, that graphic you showed that showed all the different underway devices and instruments that are on board the Healy. So in my work that I do, I focus specifically on the weather and near surface ocean observations from the Healy and other research ships through a program known as the Shipboard Automated Meteorological and Oceanographic System Initiative. So next slide, please. So what we're doing in the SAMOS initiative is we are actually collecting weather observations and near surface ocean data and working in collaboration with the vessel operators. So in this case, we're working with the technicians on board the Healy. The Healy is equipped, as Dave's slide showed, with several different weather sensors and weather instrumentation. So on the bottom, you see just a bow view of the Healy, and you'll note the mast on the bow. Up above on the left is the photo that's a close-up view of the weather instrumentation on the top of that bow mast. There's a wind sensor. I don't have a pointer, so I can't really point to them, but there's a wind sensor and a temperature and humidity sensor up there. They also have a set of instrumentation up on the main mast above the bridge, and then the blue photograph you see up there, a nice clear blue sky day, shows again some of the anemometers and humidity sensors that are on that mast. And they have those sensors both on the port and starboard side of the mast. So they're measuring winds and temperature and pressure and humidity from multiple locations on the ship, which is critical because the ship itself can actually influence these measurements depending on the direction the wind is blowing over the ship. So what we do is we actually work with the operator, and they actually take their navigation, their weather, their shortwave and long-wave radiation, their sea temperature and salinity observations, and they transmit them to our data center at Florida State University. And our role is to get those data out to shoreside users. So if we can go to the next slide, please. It's important to emphasize that users of data from these ships are not always sailing on the ships. There's a vast community of users that want the data that never step foot on a ship in the research work that they do. So what we do is we get basically observations taken every minute from the ship for these weather and ocean data. They send them to us via email, and we evaluate the observation quality. We have different automated and manual visual quality controls that we do on the data. And we, most importantly, provide feedback to the technicians on board the ship when we notice something's amiss with a sensor. Because the technicians are really busy. They're maintaining all those different instrument systems that Dave talked about. So we provide that kind of shoreside monitoring to feed to them. What you're looking at here is a graphic that actually is showing the density of the weather observations that we have received for about a 15-year period through the SAMOS program. The Healy data is one of the data sets we get, but we're also getting it from another 32 research vessels from around the world. So we get data that covers most of the globe. But one thing I would note is if you look up above Canada there, you're going to see no data in the Northwest Passage. This cruise by the Healy was truly a unique experience and an opportunity for the science community to get access to observations they rarely receive. Our user community spans groups that are doing satellite algorithm development, they're doing air-sea exchange work, and just those general folks that are working on atmosphere and ocean modeling. Next slide, please. So just as a quick example from the Healy and the benefit of the SAMOS data to the community at large and to the public, what you're looking at on the left here is a satellite data set. So basically this is a satellite that orbits the Earth and measures winds from space. And so the arrows are the wind direction, and the magnitude or the speed is in color. And on the right, you're seeing a cruise one day from 2nd of October for the Healy, and the wind speed data from the Healy color-coded by ship position. And what the community will do, the user community, particularly the satellite observing community, is they'll take the Healy's observations, they'll compare it to the satellite data, and you can see I've kind of penciled in where the ship track is, and this is off the coast of Greenland in Baffin Bay. And what they'll do is they'll use the data from the Healy to validate and evaluate their satellite observations and the satellite products. This is really important because the satellite products are one of the key inputs into numerical weather prediction models. And these are the models that are used by weather forecasters around the world to provide marine forecasts and the weather forecasts that the public uses every day. Improving the satellite winds by using data from ships like the Healy allows the forecasters to get better satellite data, better models equals better marine forecasts, which is critical for that whole blue economy our previous speakers were talking about, because this impacts commercial shipping, fisheries, and a vast range of marine industries. That's all I have, so I'll open the floor for any questions if there's time.
Thank you so much, Dave and Shawn, for joining us. That was a really interesting talk. Unfortunately, we don't have time for questions. We're a little bit behind schedule, so we need to keep moving, but it was really fascinating to hear about the work that you guys are doing and all of the work that goes into really maximizing the scientific output from Healy. We're now going to turn to our science panel, and we'll hear a series of short lightning talks, after which Jake and I will moderate a panel discussion. We will also try to take a few questions from the audience as time allows, so please feel free to send those in through the chat at any time.
Thanks. And before I introduce our first speaker, I want to echo Shayla's thanks to Dave and Shawn. I think it's just really fascinating to hear how all of the complex science work on Healy gets done, and it's just been so cool to track the vessel and its work through this program. We actually had hoped that we might be able to visit with them while they were in Boston, but they were ahead of schedule and kind of came and went from the Gulf of Maine before we were ready. So, oh well. But thanks again, Dave and Shawn. Now, it's my real pleasure to introduce the first speaker on our science panel, who is Gordon Zhang. Gordon is an associate scientist at the Woods Hole Oceanographic Institution. He's a physical oceanographer who studies circulation, internal waves, and biophysical interactions on the continental shelves and marginal seas. He also studies exchange processes between the continental shelves and the open ocean. The series so far has really focused quite a bit on sort of the north to south oceanographic connections originating in the polar latitudes and flowing down our way. But it's good to have Gordon here because he's going to discuss some of the important influences that come from the south, particularly through the Gulf Stream. So with that, I'll turn it over to Gordon.
Can you hear me, Jake? Great, thank you, Jake, and Sheila for the invitation. And I also want to, before I start to talk my presentation, I want to thank Dave and Shawn for the wonderful data. And those data are the backbone of a lot of the science we do. So I really appreciate the effort that people like Dave and Shawn put into that. So I'm going to talk about the process of cross-shelf exchange induced by Gulf Stream warm core rains. As Jake said, it's coming from the south, actually. So this work was done in collaboration with my long-term collaborator, Glenn Gawakowicz, but also my postdoc, Jabi Du, and student, Jacob Padita. So next slide, please. Before I start to talk about the specific processes, I just want to give you a background on the regional setup and in particular the warming trend we're experiencing in this part of the ocean. And if you were here 2 weeks ago, Jamie Potter from University of Rhode Island actually talked about this as well. So here I'm showing you some results from some of my colleagues at the Woods Hole. They published recently. So this warming trend has been published by a few groups. So this is one example. So on the top figure, you see they are showing the temperature anomaly or the warming trend in this general region. So we are more interested in the shelf region here. So as shown by 1, 2, 3, 4, 5, 6, 7. So the Mid-Atlantic Bight, the Gulf of Maine, North Scotian Shelf area. Clearly there is the color is red, means it's warming. And so in particular, the authors, they compiled the satellite measured sea surface temperature data over the last 40 years. and this whole region, and then look at the trend. So the panel in the middle, you can actually see. So as I highlight using the red circle, the lower part of that panel, you see that's the region we're talking about, Mid-Atlantic Bight, the Gulf of Maine, and Scotian Shelf. And clearly see there is a trend getting as we approach the more modern time, current time, the color become redder. And also on the bottom panel, you actually there's this area averaged of the temperature on the shelf and also in the slope C. So in general, the trend is consistent. So the warming rate from this analysis is about 0.4 degrees C per decade. So this is happening over the last 40 years, which is actually faster than the 100-year warming rate this area has experienced. That is about order of magnitude smaller. So it appears that the warming in this region has been accelerating in the last 40 years. At the same time, if you look at the last 10 years, so the later part of the lower two panels, the color being red, being persistently red, that means we've been experiencing some persistent warming anomaly in these last 10 years. Okay, so this is the regional setup. Next slide, please. Yeah, so people have been looking at, people from a few different groups have been looking at this. And so there are different cores of this. And one is atmospheric influence, the jet stream and the position of that. Some of my colleagues worked on that. And then also like Jamie Powder talked about the offshore influence of from the Arctic region or the subarctic region. So but here I'm actually going to talk about influence from the south, from the Gulf Stream. So maybe okay, so this is actually animation. So here I'm showing you satellite measured sea surface temperature over this entire region on a particular day, 2016. And red means higher temperature, blue means cold temperature. So to the first degree, you can see the water on the shelf is very much different from the water offshore. It's water on the shelf is very blue, it's much colder, and the water offshore is much warmer. And so from the south, we have this dark red, that's the Gulf Stream flowing to the northeast. And then the Gulf Stream is very much unstable. As you can see, the path is very wavy. And sometimes this, we call it meanders, and this meander becomes so big, it actually can pinch off from the Gulf Stream itself and form this so-called warm core rings. There are basic vortexes, and they're deep, and they're energetic. And so there are some number of them are formed each year. At this particular time, as I highlighted by the number 1, 2, 3, 5, 6, you can see there are 6 of them in a small region. As after they separated from the Gulf Stream, they actually can migrate on their own, mostly to the west, southwest. The next, please. So yeah, so the velocity or the flow inside the vortexes are clockwise. And next, please. And then so that's the vortex, and on the shelf, the water is actually the cold and fresher water actually coming from the subarctic region. A lot of them are the melt water. So the water has a quite different physical and biological or biogeochemical properties from the water offshore. And next, please. Okay, yeah, so, and then as I say, the shelf water generally is cooler and fresher and less dense than the offshore water, including the water from the Gulf Stream and also the area between, we call slope C or slope water. And so the mesoscale eddies, as I'm showing here, they migrate on their own. As they migrate, they actually often impinge or crash onto the shelf edge, as and they induce cross-shelf exchange. Next slide, please. Okay, sorry, that's I guess can you keep going until next slide? Yes, here. So though as the rings impinges onto the shelf edge, it actually can induce substantial cross-shelf exchange of the water masses, including the chemical and biological tracers. So here I'm using a paper I published a few years ago at the Mid-Atlantic Bight region to show the process. So the panel on the left, it's actually, so these are 3 images of the same region, but they're about a week or 2 weeks apart. So on the left, this particular time, there is a ring to the southeast, which is covered by the cloud. But the red means the rainwater. So right at that time, the edge of the ring touches the black contour, which is the 200-meter isobath contour, the shelf edge. And then 2 weeks later, the middle panel, you can see the red rainwater actually propagate onto the shelf and forming this very peculiar elongated intrusion pattern onto the shelf. And then another week, the last panel later, you will see there's the elongated intrusion penetrate further along the shelf edge. At the same time, there's some smaller filament moving onto the shelf. So as I said earlier, this rainwater, or essentially Gulf Stream water, is very much different from the shelf water. And in terms of temperature, salinity, biology, or chemistry, so this rain impingement onto the shelf, causing this intrusion of the rainwater onto the shelf, can dramatically affect the physical, biological, biogeochemical properties on the shelf, and also dramatically affect the marine habitat on the shelf. Next slide, please. So that's the Mid-Atlantic Bight. So now let's move a little bit to the north, looking at the Gulf of Maine, then where the Healy is heading towards, or it is now maybe. So we are looking at this region right off the northeast channel. So you can see the contours there, the black lines. The southwest part is the Georges Bank, and there is the area between the two lines. That's the northeast channel that connects the deep Gulf of Maine to the Slope Sea. And so here, again, are some satellite measured sea surface temperature images in 2017 with over 2 months period. You can see a warm core ring from the Gulf Stream migrating in that region and impinging onto the shelf edge. And on the bottom is actually in situ data that's measured at in the northeast channel by the mooring sitting at the yellow triangle. So I'm showing you over this a month or 2 months period. You can see the temperature and the salinity. So the salinity in black and temperature in red. And so you can see the temperature and both of them gradually increase, and especially towards the end of June and beginning of July, when the rains really start to hit the shelf edge, the temperature and salinity increase dramatically, and the salinity can
Gordon,
even reach.
sorry,
yeah.
This is Jake. We need to wrap up soon. So if
Yeah.
you could just make your closing points, thank you.
Yeah. So that means this rain-induced the water, the offshore water intruding into Northeast Channel and then Gulf of Maine. And then on the upper panel, I'm showing you just number of rains being generated in this region. So there apparently more rains being generated in this region. And so this offshore influence into the Gulf of Maine it's also presumably it's increasing dramatically over the last 10 or 20 years. So that's all I have. Thank you.
Thank you very much, Gordon, for that really fascinating talk. And I think it's a really nice tie-in for what we've heard in previous sessions, you know, bringing in what's happening to the south and how it impacts our region versus how the north impacts our region. So thank you very much. Our next speaker is Michelle Staudinger. She's an ecologist with the U.S. Geological Survey in the Department of the Interior Northeast Climate Adaptation Science Center, located at the University of Massachusetts, Amherst. Michelle's research takes a holistic approach to understand climate impacts on coastal ecosystem structure and function, and works to co-produce climate adaptation strategies with natural and cultural resource managers to reduce climate risk and vulnerability. Michelle.
Thank you so much, and thanks, Gordon, for kicking off this panel. So now I'm going to switch gears from talking more about the physical changes in the Gulf of Maine and the region to more biological changes. Next slide, please. From Gordon's presentation, we know that oceanographic and atmospheric forcings are causing exceptional warming in the Northeast over both annual and decadal scales. But we're also seeing really strong seasonal changes, which is leading to the earlier onset and longer duration of the warmer seasons, spring and summer, and delays in the onset and shortening of the cooler seasons, fall and winter. In this figure on the right, you can see that since the early 2000s, spring onset has occurred just about 2 weeks earlier than the historical average. And these seasonal changes are so dramatic that it constitutes a regime shift in the ecosystem state of our region. As you can see on the figure on the left, spring and fall temperature metrics have undergone 1 or more seasonal step changes in warming over the last 4 to 5 decades. Next slide. Seasonal warming in the Gulf of Maine is particularly important because this region serves as a destination for a wide range of migratory species that come to take advantage of those seasonally productive waters that Gordon mentioned earlier, to feed and to complete critical life history events. These critical life history events are known as phenological events and include activities such as migration, breeding, and development. And these phenological events occur at a particular place in time and space. In each row of this conceptual model, we show a key seasonal or phenological strategy being used by a major ecological group in the Gulf of Maine. This includes things like diadromous fishes, ground fishes, seabirds, and large pelagics. Many of these species groups provide important ecosystem services that human communities rely on for their food and livelihoods and culture. The linkages between the abiotic drivers shown as the black arrows connect things like sea surface temperature and mixing or river flow to the timing of these key biological phenological events that span across these different species groups and trophic levels. And disruptions in these linkages can have cascading effects that radiate through the system, and the responses are not necessarily the same in magnitude and duration. Next slide. In fact, we see very different and highly variable responses in shifting phenology across species and trophic levels. This figure from a recent working group that I led summarizes the results of a literature synthesis and data across the Gulf of Maine ecosystem up to the year 2018. And the results revealed that despite the overwhelming evidence for changes in the annual warming cycles, there are relatively few case studies documenting shifts in phenology of organisms in the region. This figure only represents about 20 studies in total, and as you can see from the different arrows that are vary in length and color indicating either earlier phenology or later phenology in blue and green, and the length of the arrows showing the magnitude of the shift observed in each of these studies, you can see that there's a lot of variation in the phenological responses across this ecosystem. Species are shifting in different directions and at different rates and magnitudes. So all of this variability suggests that this region is at high risk for potential mismatches in critical linkages. And this loss of synchrony between dependent species, for example, predator-prey relationships, have consequences that can result in population declines, fitness, and survival. And the species that we don't see depicted here represent gaps in our knowledge, and this limited knowledge limits our abilities to make predictions, as was discussed earlier, about the future and how to best inform management and conservation. Next slide. To close, I wanted to emphasize that shifts in phenology are just one response that is being exhibited by organisms across the Gulf of Maine and global marine ecosystems as they respond to climate change. Simultaneous to shifts in phenology, species are also shifting their range, distribution, and production levels. And when all of these responses are considered together, we see that ecosystems are rearranging and reorganizing into novel systems that have no historical analog. While many species that we have known in the region may still remain in the future, the way that they interact and the way that the ecosystem is structured and functioning may look dramatically different under future warming scenarios. In a recent working group, we envisioned what the Gulf of Maine would look like in the year 2050, given the changes we've seen to date and are expecting in the future. This figure on the right depicts the changes that we expect to see, while the figure on the left describes the ecological processes that are bringing about those changes. Overall, we expect to see declines in iconic subpolar species, including herring, right whales, and puffins, and a rise in temperate species such as squid and black sea bass. Some of these species are moving out and some species are moving into our region. Those that are moving out and those that are moving are shifting into areas that are thought to better support their thermal and ecological needs. And this includes species that have been historically important in our region, such as cod and right whales. And I know that Jen is going to talk a bit more about whales next. Thank you.
Thanks so much, Michelle. As Michelle teased, it is my pleasure to now introduce our final speaker on this panel, Jen Miksis-Olds. After Jen talks, we're a little behind schedule, but manageably so. So we are going to bring back Michelle and Gordon to have a Q&A period with Jen. But first, we want to hear from Jen, who I'm really delighted is able to join us tonight. She is the director of the Center for Acoustics Research and Education at UNH, the University of New Hampshire, which again is right down the road here, where she's also a research professor in the School of Marine Science and Ocean Engineering. She holds a joint appointment also in the UNH Center for Coastal and Ocean Mapping. She does really cool and cutting edge work with ocean acoustics, and I'm really excited to hear from Jen. Jen, take it away.
Great. Thank you so much, Jake. I'm delighted to be here and talking about acoustics because that's my passion. I wanted to just start and say that a lot of the work that I'll be talking about relates to two projects that we have sponsored by ONR right now going on in the Gulf of Maine with a project called EON. And if you can go to the next slide, please. Acoustics is such a great way of monitoring and measuring different ocean characteristics, which brings it back to the keynotes that talked a lot about the need for making actual measurements. And Gordon and Michelle both highlighted the fact that the Gulf of Maine is extremely dynamic and variable in both physical and biological processes, and having reasonably priced, efficient ways to make measurements on multiple things, acoustics provides a really great avenue for doing that. And here's an example. So right now we have 3, soon to be 4 different acoustic environmental observation network nodes in the Gulf of Maine, shown with the dots in the bottom right inset. And then the main inset shows the sound propagation of a 20 hertz signal, which is typically a frequency of fin whales, with a typical source level of 185 dB and a noise level of 85 dB. So those sensors located in the center of those dark circles, with just those 4, we are able to listen and record the sound from the ocean at those sensors and get an idea of what is happening in different aspects across the entire Gulf of Maine. So if you can go to the next slide. Passive acoustic monitoring, you can get a lot of information about marine mammals through the marine mammal detections, environmental sound levels or soundscapes. This is essential to look and identify changes related to climate. And as Michelle said, changes and shifts in biological species that are moving in and out of the area, both seasonally and in response to climate changes. Sea ice dynamics, we don't have to worry about too much about that in the Gulf of Maine. We have ocean wind and precipitation, and then we have detections of human activity. The Gulf of Maine has been identified as an area of rapid environmental change, and with that rapid environmental change are going to be changes and increases in human activity related to energy, with the Arctic Passage opening up, the Gulf of Maine on US waters. The port of Portland, Maine is going to be the first deep water port. So we expect human activity to change. If you can hit the next slide. My next the next slides are just going to focus on these two. So marine mammal detections in support of whale conservation and environmental sound levels in support of soundscape analysis. So next slide. When we talk about marine mammal detections, what can we learn from that? Well, first, we learn about habitat use. There's seasonal temporal distribution, fine scale distribution and behavior where they're feeding, and the monitoring and detections can also be used to inform conservation. This is especially important in North Atlantic right whales. So next slide. I found this image particularly striking. I know it's hard to see, but on the left side are right whale observations from 2000 to 2009, and on the right-hand side in red are 2010 to 2019. So 2 different decades of visual surveys that have gone out in the Gulf of Maine, and you can see just from the little icons where the whales were that they weren't the same in these 2 decades. The whales have shifted their behavior, they shifted where they are, and this data was extremely time-consuming and expensive to get because it was people out on boats making visual observations or in planes making visual observations. If you go to the next slide, So this particular inset was pulled from the Northeast Fisheries Science Center Passive Acoustic Cetacean Map, and it shows all of the different acoustic recording assets in the Gulf of Maine over the past decade, maybe, I can't remember exactly. And this is showing right whale detections. So imagine what we can do with the data from all of these passive acoustic recorders if they were integrated across US and Canadian boundaries to understand more about the driving factors of the right whales, not only where they are and when they're there, but active acoustics can be used for prey mapping and understanding the prey. The passive acoustic soundscape can be used for identifying how these animals are moving in relation to different activities detected through sound. And so lastly, I'd like to conclude with the last slide, providing a framework and concept for how soundscapes can be applied to ecology and understanding the different dynamics going on in the Gulf of Maine. From down at the bottom, oceanographic factors, you see soundscape in the middle. All of these things impact the soundscape, and the soundscape in turn impacts many of these other things. So soundscape can influence biotic factors as much as biotic factors can influence the soundscape. Abiotic factors influence the soundscape. Anthropogenic, the animals themselves. And so you can see that this is a very, there's a feedback loop between the soundscape and multiple different factors that we can detect with passive acoustic monitoring. And being able to get that acoustic record really provides a wealth of information to study all sorts of things, from acoustics to signal processing, oceanography, marine biology, physical oceanography. And so I hope that as people think about how best to move forward in the Gulf of Maine with monitoring, that passive acoustic monitoring and soundscapes is an active tool in that toolbox that people will be using.
Thank you, Jen. If I could ask Gordon and Michelle to fire up your cameras and microphones again. We've got, we could probably do about 10, maybe a few more minutes for a bit of a panel discussion among the three of you. There's a lot we could talk about. I think you've between the three of you have given us such a such different but together, I think, a fairly holistic view on what's going on with oceanography and ecology in the Gulf of Maine. Maybe I'll turn it to Shayla to see if you want to start off the Q&A.
Yeah, so you all gave some really fascinating presentations, and I really enjoyed listening to them. And you all discussed some really cutting-edge perspectives on the oceanography and the ecology of your region that can really help us to understand the changes that are occurring in our ocean. So this webinar series, of course, is being hosted by two ocean observing organizations, CIOOS Atlantic and NERACOOS, and I think we'd really benefit from any thoughts you might have on how the questions you're looking at and how your research and what you're learning should shape the future of observing systems. And maybe Jen, we'll start with you.
Sure. My hope would be that more people embrace acoustics as part of ocean observing systems, since it provides so much information. Historically, within the global ocean observing system, acoustics hasn't been a component of that. And it's such a rich data set to address so many different aspects that I would just promote acoustics as being part of that ocean observation as a whole and integrated across the Gulf of Maine as a whole, both nationally and internationally. The sound knows no boundaries.
It's true, and I think there's a lot of value in that. I know that there's been some acoustic observations in the Gulf of St. Lawrence as well around white whales, and that has in fact impacted some of the policy decisions, hopefully positively, for the preservation of that species.
Before we hear from Michelle and Gordon on this, I'd just like to follow up with Jen. Jen, I'm not surprised that that was your answer, and I think you're right. Do you have any thoughts on how acoustic monitoring systems, though, can or should be integrated with other aspects of ocean observing systems? And I know that's a fairly open-ended question. I mean, some of it may be after the fact in the modeling and analytical phase, but we want our ocean observing systems to be integrated. And so I just am wondering how acoustics, in your view, fit into the bigger picture.
I'm going to answer that on two different levels. A spatial level, acoustics provides a mean to integrate information coming from two very different and far away places. So two different aspects in the Gulf of Maine. Acoustics will travel between nodes. And so many of the ocean observing systems are essentially taking point samples in time. So you get a great temporal resolution. Acoustics allows for a greater spatial resolution. And when we talk about integration in from another perspective, is the data needs to be publicly accessible to all people using acoustic data and any data recorded within an ocean observation system. So it can be used broadly to answer multiple questions, not just a single one for a single project. And acoustic data is hard to manage and archive and distribute because it's just so stinking big.
Yes, absolutely. And certainly the storage of acoustic data is something within ocean observing systems that is a concern, and how that data can be made available. I know in CIOOS Atlantic we do some work with Meridian, and they specialize in acoustic data, and they've been really wonderful partners to work with. Thanks, Jen. Gordon or Michelle, what would your answers be to that question?
Yeah, sure, I can start. So I actually also want to provide my support to Jane's argument that acoustics data will be really useful for us to integrate a lot of the quantities of properties we're looking at. So I'm actually actively working with acousticians at the Woods Hole, trying to use that acoustics and then back out the physical properties, not only the travel time of stratification, but also look at the frontal variability. So you actually, so that's something. It's also kind of remote sensing, right? It is the underwater remote sensing, and it's a great tool. And we're actually working on that. And hopefully we'll make some progress in the near future, so we can make the acoustic data more useful. So, and then back to the original question. One thought I have is the long-term measurements in the, say, Gulf of Maine, which I'm actually working on. And so recently, my postdoc and I have been looking at the influence of the warm cold rains on the Gulf of Maine circulation and water properties. And we could only do that because of the existence of the NERACOOS moorings, because over the last 20 years of the data. And so this kind of the influence we're looking at is episodic. They don't occur all the time. They occur a few times. The warm cold rain that occur impinging on the shelf edge a few times a year. And so you really look at the influence and the dynamics. We need a long-term measurement. And we were able to do that because of all this mooring data, plus the satellite data, of course, and combining that together. So I think we should continue making measurements to do this. So that's a chart for you, Jake, that to trying to understand the process going on in the ocean, and then to make a prediction about the future.
I want to echo everything that's already been said. To understand shifts in phenology, we really need robust data sets over time, and at least 20 years of data is needed to truly get a sense of what's happening. Otherwise, it can be confounded by other factors that are going on, and that can happen anyway. But just to echo some of the things that have already been said, making data open and accessible. I love all the tools, the online tools that are popping up all over the place to allow people to interact with data. But one thing that I think we always have to remember is that all of the data that are collected have limitations and caveats, and we need to help people understand how to use this data correctly and how to integrate them together. That's really going to be the key, is integrating the biological and the physical data to answer these really big, complex problems. And also collecting the data at a fine scale. We know that climate change and all of the different processes that we've been hearing about today are global in scope, but happen at local levels. And so different organisms that live in different places are going to be affected, and human communities are going to be affected very differently depending on what the impacts are. So we really need that fine scale data both in space and time to understand the trends and the local impacts that people are going to be and organisms are going to be experiencing. So yeah, and then also we need better, there's always help in needing how to integrate all of these really intense data sets and going beyond currents so that we can get to information on abundance and population trends as well.
Can I jump in and just say one more thing about the integration and observing systems? I think that the community of ocean observing would truly benefit from bringing in spatial statisticians very early in development of any systems, and systems engineers that can facilitate early on during the development and not after the fact how to integrate multiple data sets over space and time to get the most out of them.
So Jen, you kind of got ahead of a question I was about to ask, which had to, which was going to build. No, that's okay. It was going to build on this theme of integration and what we do with the data. Before we go there, we did have a question come in through the chat that is to you specifically, Jen, and it has to do. I think it's a follow up to the question I asked you earlier about integration of acoustics with other types of data, but it was specifically what other observations make acoustics most valuable. Or perhaps least valuable. I think you touched on this a bit, but I think you know, specifically, what else are we collecting or should be collecting that can enhance the value of acoustic information?
Okay, so to enhance the value of acoustics, we definitely need sound speed profiles, sound speed velocity profiles for temperature and salinity. That's super helpful. Fine scale bathymetry mapping, again, very super helpful. That impacts propagation. In interpreting the acoustic signals, ground truthing things with ground truthing signals with possibly eDNA. So for active acoustics, for example, I didn't even talk about active acoustics, but you can get great spatial temporal information from echo sounders, but you need ground truthing to fully be able to interpret what species and animal groups those are. And so I think that ancillary data sets, I think I touched on the three big ones there. There may be more that are slipping my mind, but those are the three big ones.
Thanks, Jen. And you already got ahead of my follow-up question. So I think I'd like to hear any additional thoughts from Michelle and Gordon. And then unfortunately, we never have enough time for these discussions, but we'll need to wrap up this panel and get to our next one. So Michelle, Gordon, any closing thoughts you have about kind of data integration, modeling, sort of what happens after we move from observations to actual interpretation and application?
Michelle, you want to go first?
You guys can
Sure.
do a rock, paper, scissors if you.
I just think it's really important to think about all the different stakeholders that could benefit from the data that we're collecting and bring them in to help shape the questions that we're using these data to answer, and also to make sure that we do the work to communicate the results in multiple formats so that they're accessible to a wide variety of audiences, and really focus on helping people understand the consequences of what's happening right now.
Right, so my thought on this, so as a physical oceanographer, one thing I think that very important for us to move towards is this data simulation. So we know observations are very important, are key, but from my perspective, I think we'll never have enough. And so one way to fill the gaps is to integrate them, but then really systematically integration will need a model, not only numerical ocean models with physics, biology, biogeochemical components, and then put them together. And so to do it in a systematic way. So that's the data simulation. And so with that, once we do that correctly, we actually will be able to first predict what's going to happen in the near term or long term, but at the same time actually could help us to improve our sampling efficiency or effectiveness, right? So a lot of times our sampling strategy is based on our past knowledge we collect over many years, but there are also systematic way for us to optimize our observing system design using this data assimilative ocean model and observation integrated system. So I think that's, and then further improve our prediction predictability of the system. So that is I think that's something we should strive to move toward.
Thank you, Gordon. Spoken like a true scientist to say we'll never have enough data. It happens. It just so happens that I agree. But I think between you and Michelle, actually, you've hit on two really important things: the right models to try to interpret and especially make predictions with data. And Michelle, your comments were a great segue to our next panel, which we're going to turn to now, which is really making sure we engage users and figure out how to best put data to use. So. Gordon, Michelle, and Jen, I want to thank you all for joining us. Like I said, we didn't have anywhere near enough time to dig into everything we could have, but I appreciate you joining us and what you had to share.
Thank you.
Thank you.
Thanks for having us.
So it's now time to turn from the hard science to the more human dimensions of our changing oceans and coastlines for what will be the final panel of this webinar series. So first up for this panel, I think they were able to connect. I saw you appear, Paul and Denise. Assuming you're on, we're having some connection issues, but assuming you're here, it's my real honor to introduce Paul Pouliot, who is the Sagamo for the Cowasuck band of the Pennacook-Abenaki people. These are the traditional landowners of where NERACOOS now calls home. Paul is joined by his wife, Denise, who is the Sagamo Squaw for the tribe. We're going to hear some remarks from them now, and then they will join our fellow panelists for our closing Q&A. So, Paul, the floor is yours.
Why Nito Ba, Ndelawasin Denise Pouliot, Sagamo Squaw, Wadelawasin Paul Pouliot, Sagamo, Cowasuck Band, Pennacook-Abenaki people, Neona Ayan, Oranako Nipi. Hello, friends. My name is Denise Pouliot, and this is Paul Pouliot. I'm the head female speaker, and Paul is the head male speaker of the Cowasuck Band of the Pennacook-Abenaki people. We are coming into you today from Alton, New Hampshire, which in our language is known as Oranako Nipi, which translates to the place of the narrowing waters. So we are here today to discuss some dam issues, and let Paul go ahead.
We've been studying our foodways for quite a few years, and we've realized that under the influence of colonial industrialization, our foodways were disrupted from the very earliest colonial contact. What we noticed was we were actually four-season fishermen. We relied very heavily on the migratory fish that went into the Piscataqua and the Merrimack watersheds, Winnacunnet watersheds, estuaries, and the Great Bay. So we started to analyze how that impacted us. It turned out that without really knowing it, the colonial people, by putting these first dams, the first row of dams right off the ocean front, basically, they did the same thing that happened to the Plains indigenous people by killing the buffalo. They wanted to starve us out, but they didn't realize how successful they were by stopping the migratory fish flow. So today, we are trying to remove, there's almost 1,400 dams, I guess, across New England that are out there that have impacted our foodways and our waterways. We got involved with the town of Exeter, New Hampshire. They had a dam there that was the first dam from the Great Bay, and they did a lot of hand wringing and concerns about what it was going to have for impacts on the property values and all that stuff. But it came down to an economic decision that continuing to maintain a dangerous dam is more costly than, you know, repairing them and repairing it into the future. So when the dam got out, everybody was very skeptical, saying, that's not going to have any impact. The fish won't return. Well, that wasn't what happened at all. The fish returned very quickly. And, you know, they were used to seeing American eels coming into the watershed, but they, all of a sudden, all the alewives and the other herring species started to reappear. And everybody was very happy about that. Well, the town of Durham also was faced with the same thing, and that's next to the UNH campus. And after years of debate and hand-wringing, a decision was made by the town council to remove the dam at Durham on the Oyster River. And that had its own personal connection with us because we had done a documentary for the school system about the impact of removing the dam. When we did the documentary, we were at the dam site and we noticed Fish and Game was there, very diligently netting blueback herring and tossing them over the dam. So we engaged them and asked them what was going on. They said, literally thousands of migratory fish come into the dams along the estuaries that we have, and they're trapped either in fish ladders that don't work or they're trapped at the face of the dam. And they've been religiously throwing them over the dam in the thousands. And in this particular case, we witnessed them put 2,000 blueback herring over the dam. And where did they go? We could follow their scales, you know, as they moved. They were going up into the watershed around the campus, going upriver. So this was all great until a petition was created in town, and they want to overturn the town council decision on a NIMBY type of response. This is our property. We don't want it being impacted. But we are now hopeful the town will stay the course and remove the dam, just like the ones on Salmon Falls River. We see these dams as being dangerous, and we also would like to see the watershed be revitalized because we look at these locations as actual nurseries for our fish-going, you know, populations. And these fish instinctively are still trying to come into our watershed, and they're being blocked by these colonial dams, many of which are unsafe and have no historical importance anymore. So with that being said, I think that kind of chews up our 5 minutes.
So I want to thank you all for joining us, and we hope that you can join us in the removal of any unnecessary and unusable dams in the region. And we really hope that we'll see you on the trail.
Thank you so much, Paul and Denise. I hope you'll be able to stick around to join a discussion with our next panelists in a few moments. Shayla is going to introduce our next panelist. Before she does, I just want to say how glad I am that you brought the importance of rivers and their influence on the sea and the connections with sea-run fishes into this discussion. This has been a series focused mostly on the oceans, that we really haven't got into that really important connection yet. When we were talking about the Arctic, we talked about the influences of glaciers and ice caps, but as we've moved south, rivers haven't factored in yet. So I'm glad you brought that to our discussion. Thank you, and we'll see you again in a few minutes after our other two panelists speak. Shayla?
Thanks, Jake, and I'd like to echo your thanks as well to Paul and Denise. It was great to hear you speak about these issues and to bring them up. Next, I'd like to welcome Ariel Smith, the Coastal and Marine Team Lead for Coastal Action, a charitable organization that addresses environmental concerns throughout the South Shore region of Nova Scotia and beyond. Their goal is to promote the restoration, enhancement, and conservation of the environment through research, education, action, and community engagement. Ariel.
Thank you so much, and thank you for having me. I'm really excited to present briefly on our work and then have some time for discussion. To kind of create a bit more of a simple view of what we're doing on the Coastal and Marine team at Coastal Action, I'll just go over two of our projects related to the marine environment. We work in all sorts of themes at Coastal Action under species at risk, watersheds and water quality, climate change, and education. And those all weave themselves amongst each other. So it's important to kind of keep that in mind as well. And we can go to the next slide. So something that we have been working on pretty heavily in the last couple of years, we launched this in the summer of 2020, but we were working on proposals the year before and kind of pursuing our avenues for ghost gear work in Nova Scotia in 2019. We decided to kind of work with several different stakeholders on this in order for it to be the most successful project it can be. And this project is funded by Fisheries and Oceans Canada. The title of the project is Collaborative Ghost Gear Remediation in Southwest Nova Scotia, specifically looking at abandoned, lost, and discarded fishing gear. And we have several sites in the southwestern part of the province. Some of these metrics here haven't been updated for our new retrieval results. So to provide the numbers on that, over the 2 years that we conducted at-sea retrieval, so we were out with commercial fishers, retrieving benthic debris, towing for debris and collecting that at sea. We were able to collect 24.5 tons of gear in those 2 years. So we basically had 2 retrieval seasons last fall and then again this summer. And then we had around 3 more tons from shoreline cleanups and those efforts as well. We were also able to have a very successful rope retrieval project. So this was a pilot project, and this work has been a pilot project in our province and in the Atlantic Canadian region. But there was tons of buy-in from the fishing community to really contribute to this. So we diverted around 6 tons of rope from ending up in the landfill. So any of the rope that fishers were no longer using and didn't need, instead of taking that to the landfill, we had rope collection bins at 9 different wharves across the region, and we're able to collect that. We're now in the efforts, the last kind of push of this project from now until the spring of 2022. We're working on effective disposal and recycling opportunities. That is a big kind of gap currently, and we've recognized that in our work in the last couple years, is that we need more effective options for recycling the gear that we find, particularly the rope, because this rope is in very good condition most of the time. We need the capacity to shred it and then either transfer that into diesel fuel or have plastic lumber opportunities. And there are folks in Nova Scotia, in Atlantic Canada, that are working on that from the business perspective. So that's a look at the ghost gear work we're doing, a very quick snapshot. If you'd like to learn more about that, we can always chat further. And then the next project, if you go to the next slide, that I've been working on in the last 5 or so years is microplastic research. And of course, that connects to the issue of debris from fishing gear at sea. Those items break down due to sun, wind, and wave exposure and weathering, and can end up as microplastics in the marine environment. So we have done several different microplastic research projects in Atlantic Canada. We started our work in 2017 at 3 different locations of Atlantic Canada, in Western Newfoundland, in the Bay of Fundy area, and where we're situated on the south shore of Nova Scotia, in and around the LaHave Islands. And from that data, we were really able to see a very interesting snapshot of the types of microplastics that are in the nearshore marine environment. So at all sites, we did collect some degree of microplastics, and our partners, the Civic Laboratory for Environmental Action Research, analyzed those plastics for us and also provided the methods, the manual for creating our trawl, and the shoreline sediment methods as well. And we could see that the source of these plastics were often threads, which connect to the fishing industry, and rope from fishing gear, as well as fragments. And fragments, of course, are a little bit more difficult to determine their original source, but they can often be single-use plastics, larger bins or buckets or things that have broken down if they're more durable, hard plastics. And those were the two main categories when we just looked at morphology. We also took it a step further for this first project to determine the spectroscopy and the polymer type. So we wanted to determine, okay, we know that this is a fragment, but what is the chemical makeup? And the two main categories that we found, of course, they're the two main types of plastics that we use as humans, polyethylene and polypropylene. And the polypropylene connects to the type of plastic used for fishing line, or sorry, fishing rope that would be used in the lobster fishing industry heavily as a heavy, economic importance for our region. So those are the two main projects that I wanted to highlight here. And of course, there's tons more information that I could be providing, and I recommend checking out our website, coastalaction.org. What we're doing now is kind of expanding that research to more data sites. We have partners in PEI, New Brunswick, and Nova Scotia, and then we've collected data in Newfoundland as well. So just trying to expand the data set and provide more information.
Thanks, Ariel. That's great work your organization's doing up there, and thank you for sharing that. Maybe we can dig into some of the other more work when we get to the Q&A. Before though, we have one more panelist we'd like to hear from today, and that is Erin Perry. Erin is the Deputy Director of the Cape Cod Commission. The Commission's mission is to protect the unique values and quality of life on Cape Cod by coordinating a balanced relationship between environmental protection and economic progress. I think Erin is a really fitting final speaker for this program because Cape Cod sits along the far southern edge of the Gulf of Maine. So it really brings us right to the very end of the larger Northwest Atlantic domain that we've been kind of focused on over this series. So Erin, thank you for joining us, and I'm looking forward to hearing your remarks.
Sure. Thanks so much, Jake. I really appreciate you having me here today. So I'm going to spend most of my time today focusing on climate change and its impacts on Cape Cod. But before I jump into that, just a little bit of background on the Commission. We are a regional land use planning agency for the entirety of Barnstable County. So we were created by an act of the Massachusetts legislature back in 1990, so the Cape Cod Commission Act, again, in recognition of kind of those unique qualities of our region. And those characteristics that make Cape Cod a unique and desirable place are really inextricably linked to our proximity to the ocean. We are surrounded entirely by water. Two of our communities are actually split by a canal that allows for marine transport between Cape Cod Bay and Buzzards Bay, and these surroundings, kind of this direct link to the ocean, has really resulted in some of our greatest challenges. Next slide, please. As Jake identified, we are really charged with balancing environmental protection and economic progress in the region. And we're also charged with developing and maintaining many regional plans really to achieve that mission. The overarching plan, our regional policy plan, includes goals and objectives within a wide variety of issue areas. And it's really intended to provide the framework for both planning and regulation in the region. Other regional plans that we're responsible for include a regional water quality plan, a regional transportation plan, a comprehensive economic development strategy, among others. And I think you'll see if you take a look at our work that climate change is really a challenge that transcends all of our planning, all of our work, everything that we do here at the Commission. Next slide, please. We have over 586 miles of vulnerable tidal shoreline at risk today due to flooding and erosion. About 19% of the region's land areas is within the flood zone, and that includes $16 billion worth of assessed property value. Some of our critical assets, including critical facilities like hospitals, police, fire stations, municipal buildings, as well as many inventoried historic structures that are critical to our community character. And impacts to these buildings and infrastructure in these areas will have a profound effect on our entire community. As we've heard a lot about today and in prior prior sessions, the Northwest Atlantic waters are warming far faster than the global average. And by the end of the century, Cape Cod's likely to see a 4 to 10 foot increase in sea level rise. And so those impacts that we face today are likely to become significantly worse in the future. And it's so important that we continue to have access to data and modeling to really better understand our vulnerabilities. Something that the Commission just recently completed was the first Cape Cod Climate Action Plan. So working with a variety of stakeholders, we developed strategies and actions for addressing those impacts, as well as reducing greenhouse gas emissions from the region. Next slide, please. In Massachusetts, much of the responsibility for those actions really falls to municipalities, and part of the Commission's role is to provide resources, tools, and data to communities to help facilitate action and really to encourage good decision making. And so what you're seeing here is the Cape Cod Coastal Planner. It's a web-based decision support tool that was created to visualize potential climate impacts and solutions for addressing those impacts. Users are able to really look at the extent of projected sea level rise, storm surge, and erosion, and their potential impacts on infrastructure and other assets. And so what you can see here is with 6 feet of sea level rise, most of the Outer Cape, that area that's almost entirely red, is nearly inaccessible. Those red lines represent disconnected roadways as a result of sea level rise. Next slide, please. And if you look a bit closer, those areas identified in orange are 2 of the 16 community activity centers in our region. And so community activity centers are areas that are defined by a high concentration of business activity, community activity, and compact built form. They're areas where there tends to be a lot of people, and they're areas that represent the Cape's character. But for the challenges such as those associated with climate change, these are areas that the region wants to continue to invest in. And the Cape Cod Coastal Planner allows users to superimpose potential adaptation strategies on the map and really to better understand and compare the potential impacts of actions that a community might take. So next slide, please. And finally, just touching a little bit on the costs of the impacts that we face today. It's really important that we understand those costs, that we understand what they may look like moving forward. It helps us really to articulate the need for action and help drive that action. And so during development of the Climate Action Plan, we calculated the cost of doing nothing. Damages and losses due to sea level rise and storm surge alone, we now know could exceed $50 billion by the end of the century. And in the Climate Action Plan really recognizes that in order to address some of those potential losses, we need to focus both on adapting to impacts as well as contributing to slowing the rate of climate change by reducing greenhouse gas emissions. And the Climate Action Plan that was just recently released provides a framework for that action and innovation. It directly relates to and complements our other regional plans. For example, we heard a little bit about the blue economy earlier today. Promoting industries and employment opportunities in the blue economy is really key to implementation of the economic development strategy that we're responsible for. It's also critical to supporting the renewable energy opportunities that will reduce our reliance on fossil fuels. So, implementation of this Climate Action Plan it really does go hand in hand with ongoing implementation and updates to our other plans. It will, in part provide a basis for what will be a likely update to our ocean management plan, which is a plan that provides guidance on areas suitable for the installation of cables and pipelines, among other uses of the ocean. And this is a plan that's been in place since 2009 and will evolve as the nature, of the way we use our surrounding waters evolves. And so it's something I think we'll be taking on as an agency in the near term, among other efforts relative to climate change. And so hope that gives you a quick kind of glimpse on some of the impacts that we face, some of the work that the Commission does, and looking forward to the conversation.
Thanks so much, Erin. We've now got 10, maybe a few more minutes for a Q&A with this panel. So if we could ask Paul and Denise and Ariel, if you could, assuming you're still there, if you could fire up your cameras. There we go. Great. We can use most of our remaining time for some discussion. We need a few minutes just to close out at the end. We had a question come in from the audience that I'm going to take. This had to do with the fate of the Mill Pond Dam, which is here in Durham, New Hampshire. And Paul spoke to this, and the question was, is it coming out or not? And I think the short answer is we don't know. As Paul said, the town council did vote after spending hundreds of thousands of dollars on studies and months of discussion to remove the dam. But that was followed by a petition from some of the residents here in town to put that question to a referendum. So I don't think we know which way it's going to go. I think I'll just leave it at that. But I would like to actually pivot from there to a question for Paul and Denise. As I mentioned earlier, and as your remarks really focused on your tribe's interest in river restoration, sea run fish restoration, something very near and dear to my heart. I'm interested though in hearing about whether, because this is a webinar series that is kind of focused on the wider ocean, whether you have interests and activities, either other activities along the coast or interests that get out, into the blue. So I was hoping you might speak to that for a moment.
Okay, one of the things we're always concerned about is, well, I'll go back to the other issue. It's not just dams. We also look at culverts as well as being one of those other issues. Culverts which obstruct fish from migrating deeper inland. But what we're looking at is our cultural resources that could be diminished by erosion. We've got some. We don't like to talk about archaeology in detail, but we are looking at a lot of cultural resources that are going to be lost by rising sea level, ocean erosion, and other things like the other factors which are taking away some of our cultural resources. So that's also an interest to it, but we really still focus on the fishways, and restoring our what we call our nurseries, our fish nurseries that were in our estuaries, and we think that's more important than anything.
If you want healthy oceans, you have to have healthy rivers that run into oceans. So these are all things that are interconnected, and you can't focus on one without focusing on the other. We're seeing massive depletion in fish populations, and that's because we cut off the place where they breed. So if you want to replenish the fish, you need to take out the dams. That's why we call these rivers their nurseries, because this is where they lay their eggs, and this is where their babies are born, and then they come back down into the ocean. So unless you want to, truly focus on the issues here and look at the root causes of what's happening, nothing is truly going to really change.
And a lot of these dams are so marginalized now. They, everybody says, oh, they're for flood control or aesthetics or reminiscent of the industrial era, and there's no place for it. And there's so many people interested in removing them. We can't believe towns are still thinking about spending money for the future just to keep these antiquated things up there. And the Salmon Falls area, there's 2 dams there. We've inspected them. We don't understand why they're even there. There are no fish ladders. There's no way that they're actually viable watersheds anymore because of these dams.
But to go back to your original question, yes, we do get involved with a lot of projects that revolve the ocean. We just wrote a letter of recommendation for a grant to be a part of a grant that's going to do underwater archaeology to try to recover spaces that we've already lost. What we know between the mainland and Star Islands, that was all connected at one point. And that's how much water has come in during our time here on Indakina. So we know it's going to keep getting deeper. And so we have projects that we're looking at doing recovery archaeology, which is much different than the regular archaeology, because we don't care about what's left behind, because we're just looking to get what we can out before it's lost. So, we have to sometimes change our attitudes and our thought processes depending upon what's happening in an area, because we have to think of the long term, not just for us as a people, but for us as a community. And so when we go in and we have these conversations, we speak for us as a people, but once again, us as a community, because we all have to live here and share this space. And so we're all in the canoe.
We're all in the same boat, as we say. And this applies to the Wampanoags too, off of, the Cape Cod, going out to Martha's Vineyard, Nantucket. We know that's a rich cultural area, and it's really in very shallow waters. And, there's a lot of history that's under the sea, so to speak. So
and Sorry, on that, I mean, Shayla has a question I think she wants to put to Erin and Ariel, but I think just one comment I want to make following what you just said, Paul and Denise. And this goes back to your focus on rivers and anadromous fish restoration. I think it's worth acknowledging that that is a kind of stewardship responsibility that I've seen several of the indigenous communities across New England take on. Not you've been really important voices here in the New Hampshire seacoast where NERACOOS is based. But you know, the Maliseet on both sides, actually, on the Maine and New Brunswick side of the border, the Passamaquoddy, the Maliseet focus quite a bit on the St. John River, on the Passamaquoddy, on the St. Croix, the Penobscot on the Penobscot River. So it's really been great to see the indigenous communities step up as a voice and as stewards of those resources. Sorry, Shayla, I'll turn it back to you now.
No, thanks, Jake. And I think that's a really excellent segue into the question that I wanted to ask Erin and Ariel. Apologies. Paul and Denise have brought up some really fantastic points and really helped to shine a light on, you know, what sometimes can be missed in the scientific world is the knowledge and the stewardship that indigenous communities and organizations really take over our lands and our waters, and how important it is to involve our indigenous partners in the work that we're doing. And so Erin and Ariel, I just wanted to ask you, what kind of engagement do you have with indigenous partners in your areas? Do you have any success stories that you'd be willing to share?
Sure. I mean, I can start and just touch on, you know, we have a very direct kind of consistent connection with the Wampanoag tribe on Cape Cod, the Mashpee tribe. We have a member that sits on the Cape Cod Commission board, so they are engaged in our kind of day-to-day, primarily our regulatory review, but also our planning, the planning side of our work too. So I think it's really critical and really valuable that we have that consistent consistent representation across all of our work. That being said, we also, you know, we work very closely with the tribe on our regional planning processes. I think having that perspective in all of our planning processes, whether it be about climate change and the potential impacts that the tribe faces, and being sure that we integrate those into the actions and strategies that we develop, or you know, working with them on economic development strategies. That, you know, there are areas where you know, the commission itself or other stakeholders in the region, you know, truly don't have all of the knowledge and all of the information they need in order to develop some of those strategies that still, you know, really kind of preserve and promote that historic kind of indigenous population we have in the region. So they've been a critical partner on, I would say, nearly all of our efforts, and that consistent voice we have on our board is just so valuable.
Thank you, Erin. And Ariel?
Yeah, thanks for that. We have been working with the Mi'kmaq Conservation Group a little bit in the planning stages of expanding our ghost gear work. So the Mi'kmaq Conservation Group is a subset of the Confederacy of Maine and Mi'kmaq here in Nova Scotia. And they've been really interested in being involved in the ghost gear work. And so I think this coming year, as we just kind of started ghost gear retrieval this past year, we're really excited to expand our partnerships and learn from that community in terms of that work. And in terms of microplastics, I've been a part of some training opportunities with that group as well in Millbrook, Nova Scotia, to do some training on the microplastic methods that we use, and they're looking to expand their work in that field as well. So there's been some initial kind of cross collaboration and a lot more work to be done.
Thanks, Ariel and Erin. We have a question here, Ariel, for you that I want to pass along. This comes from Shawn Smith, actually, who spoke earlier about the observations underway by Healy and other ships of opportunity. And it's a nice, specific, geeky, technical question. So, and Shawn's question, and sorry, Shawn, but although I do say geeky as a compliment. Shawn's question is, how do you differentiate microplastics from fisheries debris as opposed to from other types of human debris?
Yeah, that's it's a difficult process in terms of the lab analysis component, but in once folks are trained on the process and to be able to categorize microplastics, you really start to see the differentiation. So, for example, threads from fishing rope are quite coarse, and they can be determined pretty quickly when you're looking at a sample in sediment or surface water. And they look very different from things like microfibers, which come from our clothing and are very hair-like and very thin. So it really just takes some training and getting the eye to notice these things. But the microplastic field has a lot of work to be done, at least for our region, in terms of analyzing microplastics and having that be growing our capacity. For one, we only have a couple labs in Atlantic Canada that can take on microplastic analysis, so that's something Coastal Action is working to expand here in the province. But also the expensive technologies like spectroscopy and FTIR and Raman spectroscopy, we want to have the ability to do the chemical composition, because once we look at the chemical composition, that points to the source much easier than it does when we're just looking at the morphology.
All right, great. Thanks, Ariel. Unfortunately, we are starting to run out of time. We have 5 minutes left in our session. We'd like to give all of our panelists an opportunity to make some closing remarks. Anything you want to leave us with or have us think about as we move forward in our collaborations? We'd love to hear from you. And maybe Paul and Denise, we'll start with you.
So I guess I would say, as a closing remark, don't be afraid to reach out to tribal organizations and groups. Many of us are looking to get involved, and because we've always been involved with our environment, and we're trying to broaden the Western thought process when it comes to environmental sciences. We think that if we can combine Indigenous knowledge and Western knowledge, we can come out with a whole new knowledge base that will benefit the entire world in the process. So don't be afraid to reach out. Most of the time, as long as it's environmentally friendly, we're going to be looking to be doing the same things. So
we turn out to be, we're not the scientific side of this argument or discussion. We try to put our perspective and our Indigenous knowledge into play, and we've been very successfully engaging a lot of you folks in different areas, and we have common issues, and I think we can lend another voice and another perspective sometimes. We're always willing to work with you.
Right, and the projects we've collaborated with so far have been extremely successful. So we just see nothing but brighter futures coming ahead.
Right, thank you very much. Erin?
Sure, thank you. I think I would just kind of leave with saying, we appreciate being involved in a webinar like this, and that brings together all of these different perspectives. And I think that the work that NERACOOS and partners are doing is, perhaps not always the first thing that's on the mind of those that I work with in our organization, but it is so critical to the information and the tools and the resources that we provide to our communities to better understand all of our vulnerabilities. And I think it's something that's going to be increasingly important as climate change impacts increase Cape Cod and other regions moving forward. So we just really appreciate the work that you're all doing, and again, similar to Paul and Denise, we look to collaborate in the future in any way that we can, and hope that you'll stay in touch with us. So appreciate being engaged. Thank you.
Excellent, thanks, Erin. And Ariel.
Yeah, I just want to first say thank you as well. We've started working with CIOOS Atlantic in the past year or so to get our microplastic data up on their platform. So that has been really exciting. And to share our work in this context is really great. I also just wanted to emphasize that Coastal Action's success in our project is all because of the collaboration that we do with so many different stakeholders. So we are kind of the arms that bring everyone together, but really we work with so many different people, and they have their expertise that add to the project and are really important in the success of environmental work. So I just wanted to emphasize that as well. And thank you so much.
Thank you, Ariel. Thank you, Erin, and thank you, Paul and Denise. We are just about at the top of the hour, which means it's time for us to wrap up not only this webinar, but this series. I found it to be a fascinating discussion today and in the previous two installments. We didn't have enough time, although I've probably been stretching everybody's Zoom tolerances. So we did what we could with that time, but it's been really great. And from today's webinar, I want to thank everyone who participated. I'm going to make sure I don't miss anyone. I really want to thank Senator King, Nicole, Vladimir, Dave, Shawn, Gordon, Michelle, Jen, Paul, Denise, Ariel, and Erin. I think that was everybody. Thank you all for the time you gave and for your perspectives. It would also be remiss to not send a big thanks to the U.S. Embassy in Canada once again for their sponsorship of this series, as well as the UN Decade of Ocean Science for its endorsement, which meant a lot to us.
And although you've seen Jake and I throughout the series, it's been a bigger team effort behind the scenes and of both NERACOOS and CIOOS Atlantic. So let me give a big shout out to Emily Silva, Juliana Mullen, Kelly Santos, Alexi Backerdex, Westcott, and Chen Malloy for all of their hard work behind the scenes. And we wouldn't have been able to pull this off without them.
Indeed. We had a question come in on the chat that's been answered in the chat box, but for those who are not looking at that, we are aiming, and I'm going to say we're aiming to make the recording of this webinar available because our platform had some server malfunction during the first webinar, and we only got a bit of that recording posted up. The second one, we got the full recording posted up. Hopefully this one as well, but you'll be able to get to those recordings through links on the series homepage, which will basically take you to the NERACOOS YouTube channel. So for those who missed any or all of this, you can get much of it through the recordings that will be posted, with the exception of too much of that first webinar. We are, however, planning to also produce a summary report on everything we've covered across the program. So hopefully that will fill in some of the gaps that platform crash left us with. So I think with that, it's time to say goodbye. Thank you all for joining. It's been, on behalf of NERACOOS, it's been really great to work with CIOOS Atlantic on this program, and maybe we'll do it again someday.
And likewise, it's been, on behalf of CIOOS Atlantic, it's been wonderful to work with NERACOOS, and thank you all for joining us.